So previously we explored the graphs of radical functions a little bit, and today we want to look a little bit at how the different characteristics of a radical function affect its graph. A and B represent reflections, H describes horizontal translations, and K describes vertical translations. So let's look at an example. In example 1, there's not a value written in front of the radical, so I know it must be a 1. So A is 1, and for similar reasons, B is also 1. We know that H is the value that we subtract from X. So in this case, H is negative 2. Because subtracting negative 2 is the same thing as adding 2. And here, K is negative 1. So what does this mean? Well, my H value of negative 2 tells me my graph is going to be shifting 2 to the left from the radical parent function. And my negative 1 for K tells me it's going to be shifting down 1. Let's plot some values for this. So I substituted each value into my function to see what the value of the function, my y value, would be, and now I have some points that I can plot. So my graph runs a little bit over the screen that I have right there, but you get the general idea. Now my instructions specifically ask me to label point HK, so let me do that. So I can see my H value was negative 2 and my K value was negative 1. And so this first point that I've graphed on my graph is HK. So let's describe how this graph is related to the square root parent function, y equals the square root of x. Well, just as we predicted, f of x is translated 2 left and 1 down from the graph of the square root parent function. If we were to graph them together, they would look like that. Let's try another example. So I'll follow the same process we did last time. A is 4, B is 1, H is 5, and K is 2. Based on those values, what do you think the graph is going to look like in relation to the square root parent function? Well, let's go ahead and fill in our table, and then we'll be able to graph it. So once we substitute the x values into our function, we get some points that we can plot, and we see that our function looks like that. And once again, it begins right at HK, in this case the point 5, 2. So how is this related to the graph of the square root parent function? So we could say that the graph of g of x is translated up 2, it's translated right 5, and it's stretched vertically by a factor of 4. That means that our graph here is more steep. So at this point, I want you to pause the video and try this third example on your own. Once you've got an answer and you're ready to check it, hit play again. So here's what this graph looks like. And what this means is that our graph, this time our square root parent function, was translated 5 up. It was reflected over the x-axis, and it was horizontally compressed by a factor of 9.